In this lesson, I want to talk about the terminology related to polynomials. I have listed 4 polynomials on the page: 2, 3x minus 1, 4x squared plus 3x plus 2, and negative 7x to the fifth plus 4x cubed plus 2x squared plus 4. These are all called polynomials because they have real coefficients, no complex coefficients. The x's are in the numerator and all to a non-negative power. So notice that in this polynomial 4x squared plus 3x plus 2, 4, 3, and 2 are the coefficients. They're all real numbers. Also notice that the variables are in the numerator. X squared and x are in the numerator. And then the exponents are non-negative. An exponent of 2 and an exponent of 1. Also, 2 can be written as 2x to the 0 power. It has a non-negative exponent also. These are all polynomials, but the first 3 can be written or can be called by more specific names because of the number of terms they have. We have special names for polynomials that have a single term, like the first one. We can call that one a monomial. Mono meaning 1. The second polynomial has 2 terms, 3x and negative 1. We call that a binomial. And the third polynomial has 3 terms. We can call it a trinomial. But all of them are polynomials. We don't really have specific names for any polynomials that have more than 3 terms. Some of the terminology related to polynomials includes the leading term. By the way, I've written each one of these polynomials in which the variables decrease, the exponents on the variables decrease. So the fourth one, for example, I have x to the 5th power, and then x to the 3rd power, x to the 2nd power, and then there's no x for the constant term of 4. This second last polynomial, 4x squared plus 3x plus 2, we have x squared, x to the 1st, and then x to the 0 power. So they're written in decreasing power. In that way, we can look at the very first term, called the leading term, look at the coefficient of the leading term. Coefficient of the monomial 2 is just 2. The leading coefficient of 3x minus 1 is 3. The leading coefficient of the trinomial is 4. And the leading coefficient of the last polynomial is negative 7. The term itself, like this in the last example, negative 7x to the 5th, that is the leading term. We could look at every term within a polynomial and determine the degree of the polynomial from the exponent on the variable. For example, in this last polynomial, I have the degree of negative 7x to the 5th is 5 because of the exponent of 5. The second term, 4x cubed, has a degree of 3. 2x squared has a degree of 2. And 4 has a degree of 0 because, again, we could write that as 4 times x to the 0 power. The degree of the entire polynomial is the highest degree of any one of the terms. So in this last example, the degree of negative 7x to the 5th plus 4x cubed plus 2x squared plus 4, the degree would be 5 because that's the highest power in for any one of the variables in that polynomial. The degree of the 4x squared plus 3x plus 2 would be a degree of 2 because that's the highest degree, or the highest of any of the degrees in that trinomial. We can also write or talk about polynomials that have more than one variable. For example, 3x squared plus 2xy plus 5y squared. In this case, we have a trinomial. We have 2 variables, x and y. We can look at the degree of each one of the terms. The degree of 3x squared is 2 because of power of 2. The degree of 2xy, x is to the 1st and y is to the 1st, so the degree of 2xy is 2. And the degree of 5y squared is also 2 because the exponent of 2. The degree of that entire polynomial is also 2 because that's the highest power of any one of the terms in the expression. Another example of a polynomial with two variables: 5x to the fifth y squared plus 3x squared y cubed plus 2xy to the fourth plus 7. If I want to look at the degree of the entire expression, I can look at the degree of each one of the terms in the expression. The first term has a degree of 7 because of the sum of 5 and 2, sum of the exponents. The second term has a degree of 5 because of the sum of 2 plus 3. The third term has a degree of 5 because of the sum of 1 and 4. And the last term has a degree of 0 because it could be written as 7x to the 0 power. It's a constant term. The degree of the entire polynomial is 7 because that's the highest of any one of those degrees. So with polynomials we have certain terms like the leading term, the leading coefficient, monomial, binomial, trinomial, the degree of the entire polynomial, the degree of each one of the terms of the polynomial.